Hello, this is question 14 on your June 2022 Edexcel Pure 2 paper, so the paper number 2. You have a differential equation to solve, but it starts just expressing an algebraic fraction in partial fractions, which is quite simple. So first thing, we have 3 over 2x minus 1, 2x minus 1 and x plus 1, and we have to express as partial fractions. So we're going to write a and over one of the factors, 2x minus 1 for example, and b over the other one, x plus 1. I'm going to compare numerators, so 3 is going to be equal to a times the second factor, x plus 1, plus b times the first factor. I'm going to use substitution, so I'm going to find what x makes this 0, which is minus 1. So I'm going to substitute x by minus 1, and left hand side is 3, and right hand side is, this one is 0, and this one is 2 times minus 1 minus 2, minus 1 minus 3, so minus 3b, and therefore, sorry, minus 3b, not minus b, minus 3b. And then b is going to be minus 1, and if I substitute x by 1/2, I'm going to make this bracket 0. So left hand side is still 3, and right hand side I have 1/2 plus 1 is 3/2 times a is 3/2 of a, and the other bracket is 0, therefore a is 2. So I can write this as 2 over 2x minus 1 plus, no, minus 1 over x plus 1. Yeah, this is the first part, first section. Then the question starts to be a bit wordy, so you can get lost with all the words around, or all the meaning of the question. So when chemical A and chemical B are mixed, oxygen is produced. Scientist mixes these two chemicals and measure the total volume of oxygen produced over a period of time. Total volume of oxygen produced, V, in cubic meters, T hours after the chemicals were mixed, is modeled by this differential equation, where K is a constant. Given that exactly 2 hours after the chemicals were mixed, a total volume of 3 cubic meters of oxygen had been produced, we have to solve the differential equation to show this relationship between V and T. So what we are going to do is to solve this differential equation. Remember, to solve differential equations, I'm going to put all the V's together and all the T's together. It's only that, and then I'm going to integrate. So in this case, I'm going to put this dt here, to have dt divided by this expression, and this v here under the v. Yeah, so I'm just dividing by v the whole equation and multiplying by dt, if you want to think that way. So I'm going to have dv divided by v is going to be 3 dt divided by the 2t minus 1 t plus 1. No, I'm just reorganizing that equation, t plus 1. And now I'm going to integrate. So I'm going to integrate this side and this side. To integrate this one, I have a function, yeah, and the derivative of the function in the numerator. So this is just going to be ln v. And to integrate this, what I'm going to use is what I found in the first section. So I'm going to write this expression, which is the same but with t, as partial fractions, because then it's going to be very easy to integrate. So I'm going to use this thing here. So 2 divided by 2t minus 1, and minus 1 divided by t plus 1, and I'm going to integrate it. Again, here I have a function in the denominator and the derivative in the numerator. So this is going to be ln. So v is going to be ln of 2t minus 1, and this one, again, I have function and derivative in the numerator, so ln t plus 1, plus the constant of integration. I could write c Or as I have all logs, I'm going to write, instead of this, I'm going to write ln of the constant, because any number can be written as ln. Yeah. And now, using the properties of the logs, I'm just going to put everything together. I'm just going to collapse all, if you want to think that way. So these two are adding, so I'm going to multiply it. And this is subtracting, so it's going to divide. So I can write that this is ln of c timing multiplying 2t minus 1 in the numerator and the one that is subtracting in the denominator, so t plus 1. And as the logs are the same, the functions must be the same. So I can say that v is going to be c 2t minus 1 divided by t plus 1, which is very, very, very close to what we need. If you see this expression here, the only thing that changed is that they have found c. So that's what I have to do. And to find c, I have to find in my question something that is telling me some values, like this one. It says 2 hours after the chemicals were mixed, a total volume of 3 cubic meters has been produced. So when t is 2, that's the only thing it means. So when t is 2 hours, the volume is 3 cubic meters. I'm going to substitute that in my expression and find c. So v is 3, c, and then when t is 2, I have 2 times 2, 4 minus 1, 3, and the denominator is going to be 2 plus 1, 3. Therefore, c is going to be 3. So my expression is going to be precisely what I have to find. Yeah, t minus 1 divided by t plus 1. So that's the long part. Then they say scientists noticed that there was a time delay between the chemicals being mixed and the oxygen being produced, and there was a limit to the total volume of oxygen produced. Deduced from the model both things. Yeah. So time delay, we are going to find it because they say before the oxygen is produced. That means that this volume is going to start to be positive, above 0, at one point. Until then, no oxygen has been produced. So I'm going to see when this expression is positive. Yeah, and I'm just going to do, so for C, the first part, I need this expression to be positive. T is the time, so it cannot be negative. So this expression, the denominator, is going to be always positive. If this is positive, for my fraction to be positive, this numerator must be positive. So I need that 2t minus 1 is greater than 0, which means that t must be greater than 1/2. So my volume is going to be positive after half an hour. Yeah, half an hour. And they say, I think in minutes, giving your answer in minutes. So that means that I'm going to have a certain volume of oxygen after 30 minutes. And the second part, they ask that maximum, the limit of the volume of oxygen, so which means that we need to find the maximum of V. You have an algebraic fraction. If we divide a numerator by denominator, we have 6t minus 3 divided by t plus 1. It's going to be 6t plus 6. When I subtract, these two are gone, and then I have minus 3, minus 6, minus 9. I can write my volume, my expression, as 6 minus 9 over t plus 1. This expression cannot be 0, but when t increases, this fraction will reduce, will decrease, and it will decrease almost to 0. So that means that I have like a horizontal asymptote, and the maximum value that my oxygen can have is 6, because I'm going always to subtract something that is going to be bigger and bigger and bigger and bigger. Yeah, so my maximum volume is going to be 6 cubic meters. I'm going to write max. Yeah. And that's all with this question. So this is 30 minutes, this is 6 meters, cubic meters. Yeah.